Chapter 4, Part 4. The first thing we will talk about in this section is cumulative frequency graphs. So what a cumulative frequency graph does is it shows you where percent of your data lie. So in this first one here, we're looking at sugar content for 32 drinks at Starbucks. And I'm going to start looking at it kind of up here on this vertical axis. I see 1.0. That represents 100%. So if I follow that 100% over here, I'm going to find what this dot means. That's at 50. So this means that 100% of my drinks fall at 50 grams of sugar or less. 50 grams is our absolute maximum. 100% of my drinks fall below that. So the first thing we have to do based on this graph is estimate the median of the distribution. Well, we should know that the median is the middle, meaning it should be at 50%. So I'm going to go on my vertical axis here. I need to find 50. So 50 would be 0.5, which looks like it would be right here. I'm going to follow that horizontally. Gives me this dot exactly. And following that down, looks like that would be in between 20 and 30. So my median would be 25 grams of sugar. Part B asks me to estimate the IQR of the distribution. We know that the IQR is the middle 50% of our data. So to find this, we would typically take Q3 and subtract Q1. In other words, we should find the 75 percentile and subtract where 25% lies. So I'm going to find 75% first. I know that right here would be 0.7. I need just a little bit more than that, so I'm going to go right here in the middle. And it doesn't look perfect, so we're going to kind of take an estimate. I'm thinking right there, so maybe 38. Then I'm going to subtract where 25% is, so same thing on my vertical axis. I'm going to go to 25. So here's 0.2. This would be 0.3. I need in the middle. Again, not perfect, but should be pretty close. So I'm thinking that's 15, so maybe 17. We'll go ahead and subtract these, and we get 21. Now it did say to just estimate. It's okay if your estimate is a little bit off from mine. Maybe you thought that Q1 was more at 18 than 17. Maybe you thought Q3 was more at 37. So we might be off by a few, but we should be relatively close. Typically, these questions are given to you as a multiple choice, and there will be one answer that is far better than the rest. Go ahead and try the next question. Here is my work for that example that you just tried. If you got it wrong, please take a minute to pause your video and check your answer. The next thing we need to talk about is a very specific way to describe data. All data we could have, we've talked about it, how we have categorical and quantitative data. We also have discrete and continuous data. So data is considered discrete if it can take on a countable number of values. So these numbers the number of values may be infinite or it may be countably infinite, but the main idea with discrete data is that it's something you could count. For example, I might talk about the number of students in a class. This is definitely something that I could count. I could have 1 student, 2 students, 3 students, 4 students, 5 students. Technically, does this go on forever? Yes. I could have a class of 4,000 students and anything between 1 and 4,000. But because I'm able to count the number of students, this is called discrete data. Our next example is called continuous data. Continuous data or a continuous variable can take on infinitely many values, but those values cannot be counted. So the main difference is that we cannot count continuous data. No matter how small the interval between two values of a continuous variable, it's always possible to determine another value between them. So here's our example. I might care about the height of a student. And you might say, well, Mrs. Soto, I could count this. I could have a student that's 55 inches, or I could have a student that's 56 inches, or 57, or 58. But what's happening here is we're missing this whole kind of area between 55 and 56. Is it possible that a student is 55.009 inches? Sure. Is it possible they're 55.010 inches? Absolutely. Is it possible that I want to be very, very, very precise and I measure their height to be this? Absolutely. There's no stopping point, there's no starting point. It is impossible to count all of the different heights. If you can't count, then it is continuous data. So far we've learned how to do quite a bit on our calculator. We know how to find the median, and we know how to find the IQR by finding our Q3 and our Q1. We haven't exactly talked about how to find the mean and standard deviation yet, so I want to make sure we talk about how to find those on our calculator. Now your calculator will tell you the mean and the standard deviation. Unfortunately, they're not going to write out these exact words, they're going to use some notation. So anytime that we're trying to find the mean, we need to look for X bar. It's a little X with a bar right on top. Anytime we're looking for standard deviation is just denoted as a lowercase s. On your calculator, we will look for X, and we will look for S sub X. So an S with a little x right next to it. So for our example, I give you some data here. We're going to use our calculator to find the mean and the standard deviation. Let's start with plugging this into our stat. So we're going stat edit, and I'm going to type in the data. So 90. Okay, after I have my data typed in, I'm going to go to stat, calculate, and just like I did for finding mean and IQR, I'm going to number 1 where it says one variable stats. My data was typed into L1, so I'm going to go down to calculate. For mean, we said to look for X bar. It should be this very first thing that your calculator lists. So my mean for this data is 50.625. For standard deviation, we're looking for SX. So SX is right here. It gives me 28.91. So what this means is that the average for this data was roughly 50.6. So let's say, I don't know what this data is representing. Maybe it is grades in a class. Well, that means that the average grade is 50.625. My standard deviation is quite large. It's at 28. So that means that on average, my scores are 28.9% away from that average here. The larger the standard deviation means the more spread out your data is.